So today we are going to start multi-threading. Okay. Hello. My voice is not clear. Okay, 1 minute. My voice very low. Volume low according to. Okay, 1 minute. Okay. It's okay. Hello. Okay, okay. Okay, so today we are going to start multi-threading. Have you any idea about multi-threading? Yes. If we want to execute multiple tasks simultaneously, so we use multi-threading. Okay, so here that word is multi-threading. Okay, so suppose we can write it as multiple, sorry, plus thread. We can write it as multi-threading. We can convert it as multiple plus thread. It's okay. And one thread represent single task. Okay, so means multiple thread means multiple task. Okay, one thread represent one thread execute one task. So multiple thread means multiple task. So if we want to execute multiple tasks simultaneously, we use multi-threading. Understood? Okay. Multi actually it through the multi-threading we can perform multitasking process. But multitasking is a property of characteristics of operating system. Okay, like suppose Windows is a multitasking operating system. Means we can perform same time. Here we are using Google Meet and internet means Chrome. We are using STS. Okay, and here you can see here I have already opened this PowerPoint. So we can execute multiple tasks simultaneously in Windows. Windows is a multitasking operating system. So actually multitasking is the property of characteristics of operating system. We can't perform multitasking operation. Okay, but Java provides us a concept multi-threading. With the help of multi-threading, we can also perform multitasking operation. Like I think you know that DOS. Here, suppose this is a DOS. Suppose here we can execute at a time only one task, but Windows we can perform multiple tasks simultaneously. In Nokia mobile, you can perform only one task, but in a smartphone we can perform multiple tasks simultaneously. Okay, so actually multitasking is the characteristics of your operating system. We cannot perform in a normal program, but Java provides us a concept multi-threading. Through the multi-threading we can perform multitasking operation. Okay, so actually multitasking, there are two types of multitasking operation. First is called process based, and second thread based. We can do we can perform multitasking operation on the basis of process based and thread based. So we cannot perform multitasking process based. That is the characteristics of operating system. We cannot do this, but we can perform multitasking through the thread base. Java provides us a concept multi-threading. Through the multi-threading we can perform multitasking concept. Okay, understood? Next, what is the process? Actually, there are two types of process. This is a process based and thread based. What is process? Actually, in your computer architecture, what is process? So try to understand through this figure. I think uh, you are know this. You have you are already aware with this figure. That is a main main memory, CU, LU, input, output. Okay, so we can input anything like text, image, audio, video, and we can also input commands, different types of commands. Okay, so when we will input through the keyboard, mouse, we have that's called data, and output is also called information. Okay, so we can input anything like data or commands that will reach at CU, C control unit. It will reach, it will check which type of input it received. Like suppose we input a text, so it will save in main memory. And if you will input a arithmetical or logical operation, so CU transfer that operation to LU. LU is the arithmetical logic unit. Arithmetic logic unit, it calculates that uh, equation and problem, and save that result in main memory and show on the screen, uh, output screen. That is called output or information. So input or output, this portion, okay, accept data input and output, this called process. After input a value and get the output, between the input output, all operation that will perform, that's called process. And this process performed by CPU, central processing unit. Okay, so actually our CPU perform one task at a time, because that's the human made thing, and we can also perform one task at a time. Okay, so our CPU, our CPU of your system is also performing only single operation at a time. Okay, so we cannot perform multiple tasks. So if suppose we want to perform multiple tasks, so we have need multiple CPU. But suppose we want to perform multiple tasks through a single CPU. Okay, so we can use multi-threading concept and multitasking concept. Okay, so actually our CPU perform two types of operation, two types of process, you can say. First is called heavyweight, and second is called lightweight. Okay, heavyweight process acquire space in the memory, plus it have a unique process ID. Okay, but lightweight process, it does not consume any space in the memory, and it have not any process ID. It uses space of heavyweight and process ID. Okay, actually lightweight process execute within the heavyweight. Suppose heavyweight acquire a space area like this. Okay, in memory. Okay, and lightweight process use this space for execution. Okay, it it does not consume any extra space in the memory. Okay, it uses heavyweight space and process ID. So actually lightweight process execute within the heavyweight. Like suppose you can see here, suppose we are writing a email address or word, suppose MS Word acquire a space in the memory. Okay, and suppose we are uh, we want to type something in MS Word, like here. Okay, here you can see this there is a error BOI, that is a spelling mistake. It means a program is executing in the background that is checking our word, our writing. Okay, that is an example of thread. It not execute it. No, it will not acquire a extra space in the memory. It is executing within this software. Okay, that is a thread. You are using WhatsApp. You will type some. Suppose you want to send some message. You will only type this later. You can see here. There are display multiple uh, suggestion on the top of a keyboard. Okay, it means a process is executing in the background that is checking your keyboard, which you input. According to that, it will show suggestion on the top of the your keyboard. That is the example of thread. Okay, it is executing within the your software, your program. It will not acquire extra space in the memory. So we can create unlimited uh, thread as per your requirement. Okay, so at a time, if you want to see this, so here, so thread, there are two types of process executing by your CPU: heavyweight and lightweight. Heavyweight acquires space and it have a process ID. Process ID, what is the process ID? Having any idea about this? Like suppose here you can see this. Suppose I think your name is Sagar and Kirtana and Harish. Uh, okay, so we are identified through the name, but in uh, examination hall, we will identify through our roll number. In bank, we will identify through the account number. Okay, same thing. CPU does not know about what is MS Word, what is the Excel, what is Google. Okay, so actually CPU identifies through the process ID of each executed program. If you want to see this, here you can see this. Suppose here my screen is visible. Okay, you can see here. CPU doesn't know about what is Word, MS Excel. It identifies through the process ID. It will automatically generate a process ID for each process. So here you can see the task manager. Open your task. So each process has its own process ID, a unique ID. Process that is called PID. 1 minute. Here you can see this PID. Each execution have its own a unique ID. That is called process ID. Okay, so if you identify each process through the unique ID, that is called process ID. Okay, so each process acquire space in the memory and it have a process ID. But lightweight is not acquiring a space in the memory and it have not process ID. It is also called thread. Okay, lightweight process is also called thread. Means thread is not acquiring any space in the memory and it have not process ID. Okay, understood? And this concept is a very important concept of Java, and Java also work only on the basis of thread. Means your main method is also a thread, and like connection, string, your servlet, JSP, Spring Framework, Hibernate, these are all lightweight process. That's work on the basis of thread. Okay. So we cannot create process-based multitasking thread. We can perform thread, multi-thread, multitasking through the multi-threading. So how to create it? So Java provides us two methods to create the thread. First, runnable interface. Are you know about interface? Okay. So we have two options. First is runnable interface and second is thread class. Suppose here we have a class, suppose, okay, and we want to convert this class in thread. So we have two options. First is implement runnable interface, okay, and second extend thread class. Okay, we can use anyone. Implement runnable interface or extend thread class. Okay, runnable interface and thread class provided by Java. Okay, so interface runnable. I think you know that if we are using any interface and that's our responsibility to implement all method of that interface. I I think you here I think abstraction. Okay, so if here we use, this is a abstract method here, interface. Circle have circle is an interface, it have a method. So I have implement in circle impl class. Okay, and here you can see here. Okay, so this is our responsibility to implement all method of interface. Okay, same as this interface, runnable interface have a method name is public void run. So if we are using, we implement runnable interface, so must be implement public void run method. Okay, same as if we extend third class, so we will implement public void run also. In both cases we will implement public void run. But you can say why uh, in the case of thread, why we are implementing public void run? Actually, the third class, this interface, runnable interface, and class thread is implements runnable interface. Okay, thread class already implemented runnable interface, but it's not performing, it's not implementing public void run in thread class. So in both case, if you are using runnable interface or thread class, in both situation, we will implement public void run method and write the code of that task within this run method. Understood? Okay, but suppose we want to execute 10 tasks simultaneously. So we will create 10 thread, and each thread will perform a operation, a task, and we will write the code of that task in public void run method. Okay, it means without public void run method, we cannot imagine any thread. Okay. So suppose we want to create some thread examples. Okay, understood? Okay, so suppose here I'm going to create example of multi-threading. Thread pro 1. Any doubt, any queries? Others member? Okay, here. Suppose I'm going to create a class first. Okay, and we want to convert this class in thread. So extend thread class or implement runnable interface. Okay, in both cases we will implement public void run method. Okay, suppose we are going to create multiple thread. So here first second, third. Suppose we have three thread, first, second, and third. Okay. Suppose to the first, uh, okay, 1 minute. I'm going to create first of all a main method, main class. Okay. So suppose example, this is example, and it contain public void run method. Okay. This is a main method, and here, uh, here you can see this. This is a runnable interface, and this is a thread class. So thread class provide us multiple predefined methods like start, current thread, set name, get name, eld, join, sleep, etc. Okay, it provides many predefined methods. We will use one by one in programs. Okay, so here suppose current thread, it will return, it is a static method, and it will return the object of current executing thread. Okay, so suppose we want to check any thread is working in this time. And okay, so for this purpose we have thread that name is current thread is a method. It will return the object of current executing thread, and current thread is method is a static method. So we have not need to object of thread class. At the place of this we use thread class name and dot current thread. Okay, and we can save the object of current executing thread in a reference of thread class. And these class, like thread class or runnable interrupt, these are belong to java.lang package. So we have not need to import any class. Okay, so it will return the object of current executing thread. Suppose we want to print it. What is the name of current executing thread? So here thread name plus t dot get name. It will show the name of current executing thread. Okay, so now I'm going to execute this example class. Main thread name is main. So actually this main method is also a thread. So totally work in the Java performed by we will perform by thread, because thread is not acquiring a space in the memory, so it is very fast compared to another method. Okay, so each and everything in Java performed through the thread. Main is also a thread, and it will execute our thread. We will create user defined thread like first, second, third. We will create this thread. So main thread will execute your threads. Okay, and we can also execute each and every program through the main, and main is also a thread. Okay, so if we are declaring here three threads, first, second, third, and main. So if you suppose we will execute all this program, so it will execute 4 thread at a time. Okay, because main is already executing in the background, and first, second, third are user defined thread. Okay, any doubt, any queries? Okay, suppose we want to copy this, and I'm going to get the program first, second, and third thread. And suppose we want to print each thread 10 times. Okay, so main is already executing in the background. Main thread have already a name, and we can also set the name of all thread, like t t dot set name. Suppose here I've set first. Okay, and then here I'm trying to print the name of thread here. Okay, same as I'm going to create task for other method. Open second, this second thread, declare here third thread. Okay, so we have three thread. First thread is the first thread, second thread, and third thread. Suppose we want to execute all threads simultaneously. So first of all, we will create the object of these thread. Okay, so first of all, I'm going to delete this and create the object of threads, user defined thread, like first t1 is equal to new first, second t2 is equal to new, okay. So first of all, create the object of all user defined thread. After that, suppose you want to execute this, so thread class provide us a method name is start. So we use this method and start the execution of threads. T1 dot start, T2 dot start, and T3 dot start. T2 and T3. And now I'm going to execute this. Okay, here you can see this first one time only, second, after that third, and then second. Okay, but you can say what is the new in multi-threading. So actually all threads are executing simultaneously, but our CPU is very fast, so it is executing very fast, so I can't see uh, our task is executing simultaneously. So for this purpose we can stop the execution for some time, like suppose here I declare here another thread, another method, that is sleep. Sleep is also a static method of thread class. So thread dot sleep, and here we can specify the millisecond. Suppose here I have declared 1000. 1000 millisecond means 1 second. Okay, but here it's showing error. Actually, it's throwing exception try catch surrounded with try catch. Okay, that is a compile time exception. Okay, so please add try catch, and you can see here, sleep here. So interrupted exception is also a compile type exception. You can say checked exception. Okay, you can see here, this is a interrupted exception that can be arise in multi-threading. Okay, so same thing I'm going to add in other thread, thread dot sleep 1000. So it will break for 1 second in each iteration. Okay, so we can see our program is executing in simultaneously or not. Okay, so here, okay, and same as we can declare here also thread dot sleep for 1 second, and we can add try catch. Okay, now again I'm going to execute this program. So open example, and here, and you can see this third, second, first, third, second, first, third, first, first. Okay, so you can see here all threads are executing simultaneously. Okay, and we cannot fix the sequence of execution. Here you can see this. It execute third first. Okay, third, then first, second, then first, then again first, then third, then second, third. So we cannot set the sequence of the execution of thread. Okay, we will learn why it's we cannot fix the sequence of the execution of thread. Okay, first thing. Okay, so for this purpose we can see the life cycle of thread, so we can easily understand why we cannot set the execution sequence of the execution of thread. So actually I'm going to explain life cycle of thread, means how to start a thread and how to end a thread. Okay, suppose here, okay, the first is a new state. Second is a runnable state. Third is a running state. Fourth is a terminate state. And this is suspended or blocked state. Okay. So you can see here, when if we are creating a object of a thread with the help of new keyword, that is called new state of a thread. Okay, this is a new state. Okay, after execution of start method, okay, after that start method will execute, then all thread will be transferred from new state to runnable state. Means suppose we have create here T1, T2 and T3. Okay, after execution of start method, all thread will transfer from new state to runnable state. Okay, but at a time only one thread will be executed. Which thread will get the process cycle of CPU? So suppose T2 will get the process cycle of CPU. So that will transfer from runnable state to running state, and you will start the execution of its task. Okay, but how to change it? So actually thread here in Java, it's using two types of scheduler. I think you know that operating system is also use short term scheduler, long term scheduler, medium term scheduler. Same as Java is also using two types of scheduler. First, round robin, priority base. Okay, so suppose here we have three T1, T2, and T3, three thread. Okay, and T1 have requirement of 3 seconds. Suppose, okay, T2 have for execution. T2 have requirement of 5 seconds for execution, and T3 have requirement of 2 seconds of the execution. Okay, so CPU give uh, only very small time slice for the execution for each thread. Like suppose CPU give 1 second to T1. So after execution of 1 second, it will give another 1 second to T2 and 1 second for T3. And this cycle will continue. And again, CPU provide 1 second for T1, 1 second for T2, and 1 second for T3. T2, T3 have completed, then it will provide CPU provide 1 second for T1 and 1 second for T2. T1 has completed, then other time slot will be provided to T2. Okay, so all thread are working 1 second suppose, but actually the time slice very small. But here for only explanation, I I told you that is the 1 second. Okay, so a 1 second it's provide to all thread. So each you will feel like all threads are working simultaneously, but at a time only one thread is executing. So which thread will get the process cycle of CPU that will load in the running state, and after execution of their time slice, it will transfer from running state to blocked state, and when it will transfer to running state to blocked state, T1 or T2, anyone will get the process cycle. That will get the process cycle that will again transfer from runnable state to running state and start the execution for 1 second or their time slice. Okay, and T2 transfer from blocked state to runnable state automatically. Implicitly transfer from the blocked state to runnable state and wait for wait for process cycle. Okay, after completion of the T3 time slice, it transfer to blocked state, and which one will get the process cycle that will load in running state. Okay, and after execution of their time slice, it will again come in a blocked state, and after that it again come in runnable state. When it will get the process, it again come in running state. Okay, so after completion of their task, it will terminate from running state to terminate state. Okay, understood what I'm saying? Others, Kirtana and others, Nirmala, Hari Prakash, and Vishwa, Pradesh. Okay, suppose next thing. Suppose T1 is executing or T2 are executing or T3 executing their time slice, but they have requirement of input output values. Okay, so they will not wait for the completion of their time slice. It will transfer from the running state to blocked state. Okay, or we uh, we are using sleep method, then that thread transfer from running state to blocked state. If you are using suspend method or wait method, so thread transfer from running state to blocked state. Okay, so there are many situations. If thread have requirement of input output values, so it will transfer from running state to blocked state. It will not wait for the completion of the time slice. Okay, if it have a requirement of input output, it will transfer from the running state to blocked state. If we are using sleep method, so in this situation it also transfer from the running state to blocked state. If we are using suspend method or wait method, it will transfer. Suspend and wait both are transfer. Here in sleep we can specify the time slice, the time, suppose 1 second, 2 second, but in suspend method and wait method, both are transfer the thread from running state to blocked state for unlimited time period, infinite time period. Okay, so input output first. Suppose thread have requirement of input output value. So when we will submit the input out value, it will transfer from the blocked state to runnable state. Okay, if we are using sleep method, so after timeout, suppose we have declare 1 second. So after 1 second, it will automatically, it will implicitly from transfer from the blocked state to runnable state. Okay, and if we are using suspend state, so after execution of resume method, it will transfer from blocked state to runnable state. Okay, and if you are using wait method, so notify or notify all method. We can use anyone, notify or notify all. After execution of notify and notify all method, the wait method, which method is waiting in blocked state, where it transfer from the blocked state to runnable state. Okay, so if thread have requirement of input output values, so it will transfer from the running state, and after submission of submission of input output value, it will transfer from blocked state to runnable state. If you are using sleep method, to after timeout, it will transfer from blocked state to runnable state. If you are using suspend method, so after execution of resume method, it will transfer from blocked state to runnable state. If we are using wait method, so after execution of notify and notify all, it will transfer from the blocked state to runnable state. Okay, and if suppose we want to transfer our thread directly from running state to runnable state, okay, so we use yield method. It will transfer after completion of the time slice, it will transfer directly to running state to runnable state. If you will transfer directly to runnable state, we can use yield method. Otherwise, it will transfer blocked state, then it will transfer to runnable state. Okay, so that is a life cycle. So here we cannot set the sequence of the execution of thread, because which thread will get the process cycle of CPU, that will load from running state to runnable state to running state. So we cannot set the sequence of the execution of thread. Okay, any doubt, any queries? Rest of all okay. Suppose here, so there is a, that is execution of simple first, second, third, and 3 method, and we are using here thread class. But suppose we want to perform same operation using runnable interface. So what are the difference between runnable and thread class? So I'm going to create a copy of this project, and we are going to perform same tasks, same operation with the help of runnable state, runnable interface. So first, so here I remove this, implement runnable. Okay, copy this, and okay, so here we are using runnable interface at the place of thread class. Okay, so here you can see here we are, you can see here start method is showing error, because we are using interface runnable, and runnable interface have only single method, public void run, and start method is a part of thread class. We are not using thread class, we are using runnable interface. Okay, so that is a problem, so it's showing error. So how to remove this? So for this purpose, we will get the support of thread class. So how it is possible? So for this purpose, we will create the object of thread class, like thread x is equal to new thread and pass the object of user defined thread class. Okay, so we will pass the object of user defined thread in the constructor of thread class. Okay, after that, here we use x, y, and z. Okay, removed. You can see this. All errors are removed. Now we can execute this. Okay, first, second, third, first, second, third, first, third, second. Okay, so if we are using interface, reliable interface, so uh, after creating the object of thread class, we will transfer that object in the constructor of thread class. After that, we will use start method. Okay, now we are going to show the presentation of multi-threading. Okay, so multi-threading. Okay, multi-threading is a process of executing multiple threads simultaneously. If you want to perform multiple tasks simultaneously, we use multi-threading. Okay, a thread is a lightweight sub-process. Sub-process, it is not a process, it executes within the process. Okay, so a thread is a lightweight sub-process, the smallest unit of processing, and multi-processing and multi-threading both are used to achieve multitasking. So we can perform multitasking through the help of multi-processing and multi-threading. Okay, and multi-threading mechanism, we use multi-threading than multi-processing because threads use a shared memory area. They don't allocate separate memory area, so save memory and context switching between the threads takes less time than process. It is faster than a process because it does not require space in the memory, so it is faster than process. Okay, advantage, it does not block the user because threads are independent. All threads are independent. You can see in uh, we cannot interact with each other. Okay, but we have some method we can interact, but basically they are individual. They are executing individual. They are not interrupting any other thread. You can perform many operations together to it save time. So we can perform uh, multiple tasks simultaneously. Okay, so it saves time. Threads are independent, so it doesn't affect other thread. If an exception occur in a single thread, if exception will arise in any thread, so it will not affect it to another uh, execution of another thread. Okay, that is the advantage of thread. Multitasking. So multitasking is the process of executing multitask simultaneously. We use multitasking to utilize the CPU and minimize the idle time of CPU, and multitasking can be achieved in two ways: process-based multitasking and thread-based multitasking. Okay, process-based multitasking, that is a characteristic of operating system. So each process have an address in memory. In other words, each process allocate a separate memory area in the memory. Okay, a process is a heavyweight. It is also called heavyweight process, and cost of communication between the process is high. And if a process want to communicate with another process, so the communication card is very high, and switch from one process to another requires some time and for saving and loading register, memory map, updating list, etc. There are multiple tasks will be performed if we want to switch from one process to another process, but we can perform same task in multi-threading. It is very simple, very easy. Okay, thread-based share the same address of space. A thread is a lightweight and cost of communicate between the thread is very low. Very easily we can communicate with each other. Multithreading. Multithreading in Java is a process of executing multi-thread simultaneously. Okay. A life cycle, thread state, new, that is the active or runnable, you can say, blocked state, time waiting, and terminate. But you can say new and runnable, running state, and blocked state. Okay, yes. And how create a thread in Java? So we have two options, thread class and runnable interface. And thread class have the constructor like thread, uh, and so we can pass string name, and we can pass also object of runnable interface class, and implement the runnable interface class. And thread class have two parameter. Well, there are four constructor of thread class. There are two parameter, first is runnable interface and second is string. Example using thread class I have already given you. Okay, so thread class, these are the methods of thread class. And new state, active state, runnable state, running state, blocking state, awaiting state, terminate state, life cycle of thread, and implementing of thread state. Okay, so that is the presentation. Okay, so that these are the basic idea of your thread. Okay, so please check it. If you have any doubt, any queries, you can share with me.